Good morning, students. I hope you might have studied all the notes which I have given you earlier. And now, today, I will start the new topic, set theory. I would like to ask you how many of you are aware of the school result? Maybe very few. I'm glad to inform you that this year also our school has got a tremendous result. This year our school got the second rank holder in this state, and in district that is the topper. So congrats to every students and the teachers who has worked out so hard to make such a successful result. Now it is your turn to bring out the excellent result, and for this you need to work out right from beginning. So in this particular difficult time, you are getting a lot of time for practice. Make it sincere effort and do it. Otherwise, you will have to regret when the time is over. Okay, anyway, let us begin the new topic, that is set theory. It is a collection of a well-defined object. For example, collection of all even prime number. How many even prime numbers are there? Only two. Collection of the names of all prime ministers of India. Collection of the name of players of India who won 1983 World Cup. But if I say collection of mathematics books, it is a vague statement. Which class, which author, which publication, it is not clear. But once I say collection of mathematics books from 6 to 12 of R.D. Sharma, very well, you can go and collect 6, 7, 8, 9, 10, 11, 12 books. So this kind of the collection, we call it as a set. Normally, this set is denoted by capital letters of English alphabets. As A, B, C, X, Y, Z. And theoretically, the elements of this set is denoted by small letters, but practically it is not possible. Sometimes it is not always the elements will be a small letter. Sometimes it may be numericals also, sometimes it will be language also. So theoretically we say that it is denoted by the small letters of English alphabet. the elements of set are denoted by capital letters of alphabets. Now, suppose you have A is equal to 3, 7, 9, 8, 4, 2. These are called elements, and elements are also known as the member. So we can say that 3 belongs to A. 3 belongs to A means it is called as 3 is a member of A. But if I say 11, is it a member of A? No. So we say it is called 11 is not a member of A. Then the question is here, how shall we write down the elements of this set? So, methods of writing the sets. First is roster method, or it is called listing method also. Second is set builder form. In this case, what we do, we used to write the elements in a curly bracket with the comma between two consecutive member. Like A is a set of a natural number. So what happens? It is given 3, 7, 9, 8, 4, 2. So all the elements are written in a curly bracket, as well as there is a comma between the two consecutive terms, two consecutive member. Now, so what is this roster form? Roster form means you are going to list the elements in that particular form. For example, roster form. In this form, the elements of a set are written within the bracket, within the, you can say, curly bracket, putting comma between two consecutive elements. And if an element is repeated then it is listed only once. Second note, if there is 3 dots at the end, means there are infinite number of elements. So for example, let us say V is equal to A, E, I, O, U. What is this? These are the elements of V. Now, what is called set builder form? In set builder form, it is denoted by some variable, and that variable indicates a common property of every element. Alright. In this method, every element of a set has a common property which is denoted by a variable. I'll just give an example. A is equal to x such that x is a natural number and x is greater than equal to 4 but less than equal to 10. So x is denoting as a particular property. What is that? That should be a natural number. And there is a specification, there is a condition. What kind of natural number shall we take? Those number which is between 4 to 10. And therefore, if you want to write in a listing form, the listing form will be 4, 5, 6, 7, 8, 9, 10. Why? Because it is given x is greater than or equal to 4. You might have studied about the different symbols. That's why I didn't discuss. Samir sir has told you in the beginning of the classes important symbols, introduction. So in that case, you might have studied about these symbols, less than or equal to, more than or equal to, get this open bracket, close bracket, everything you have studied. That's why I didn't repeat, but sometime I will repeat it wherever it is required. So this is 4, 5, 6, 7, 8, 9, 10, and I would like to say this n stands for what? Natural number. Q stands for what? Rational number. Z stands for what? Integers. R stands for what? Real number. And C stands for what? Complex number. Sometimes it happens that it is given plus, means positive rational number, positive integer, Z minus negative integers. So all these symbols, time to time you will come to know what does it mean. Okay, now let us take another example. B is equal to x says that x is equal to n by n plus 2, where n belongs to capital N. How many numbers are there? Natural number. N belongs to capital means natural number. How many natural numbers are there? Infinite. Hence, the set of B will be also infinite. And what is your N? N is your natural number. The value of X will always taken as a N as a natural number. But the value of X will be infinite in number. So, if you want to write in the listing form, what can you say? You can say here x is equal to 1. So 1 by 3, 2 by how much? 1 plus 2 3, then 2 plus 2 4, then 3 plus 2 5, then 4 plus 2 6. So 3 4 5 6, 1 2 3 4, and just to put it as 3 dots. Let us take another example. Say C is equal to x such that x is a prime number x is greater than 72 but less than 100. What is the specification? What is the property? What is the characteristics here? X, which indicates that your prime numbers must be between 72 to 100, where neither 72 is included nor 100 is included. If suppose it could have been, I could have given you 71. So you are asked to find out this prime number more than 71. So 71 is a prime number, but we cannot take. Why? Because it is given x is greater than. If it could have been given as equal to, then it could have been collected. So I have been given here, say 72, more than 72 but less than 100. Let us list it. 72 not, 73 yes, 74 not, 75 not, 76 not, 77 not, 78 not, 79, 80 not, 81 not, 82 not, 83, 84 not, 85 not, 86 not, 87 not. 87 is not a prime number because it is divisible by 3. 88 not, 89, 90 not, 91 not because it is divisible by 7 as well as 13. 92 not, 93 not, 94 not, 95 not, 96 not, 97, 98 not, 99 not. So what is your list of this prime number? It is 73, 79, 83, 89, 97. These are called the prime numbers between 72 to 100. So these are the specification of this set builder form. Some more question I will discuss. Let me discuss few definitions. After that we will discuss the questions. Now let us take another one. Some important definitions. Some more definitions. Types of set. First, empty set. What are called empty set? The set which does not contain any set. A set which does not contain any element is called empty set. This empty set is denoted by, phi or blank curly bracket. Do you know what is the another name of empty set? It is also known as empty set as null set or word set. Now, let us say one example here. A is equal to x such that x is a student who study 30 hours a day. How many hours are there in a day? 24 hours. So it is not possible for a student or for any person to study 24 hours, 30 hours a day. That's why it is called empty set. Second example you can take x such that x is an integer, x is greater than 5 but less than 6. What are the integers lying between 5 to 6? None. So there is no integer between 5 and 6. So B is called empty set. Now let us take another example here. What is the difference between difference between 5 and bracket 5? Are they same or they differ? They are really differ. 5 stands for null set or word set or empty set. But when we talk about 5 in the curly bracket, what does it mean? It is a set. It is not an empty set. It is a set with the element phi. So once this phi is written in the curly bracket, it becomes a set, and that kind of the set is called singleton set. So what is called second singleton set? A set which contains only one element is called singleton set. For A is equal to 5, B is equal to A, and so on, because it contains only one set. Then we come to finite set. Such set is called finite set whose elements are countable. Such sets are called finite sets. Whose elements are countable. or the counting of the elements come to an end. The counting of the elements comes to an end. Let us take an example here. Say A is equal to x such that x is a prime number less than 30. We can easily count. X such that x is a vowel. What are the vowels? A, E, I, U. You can count it. X such that x is a natural number less than 500. It is also countable. So whenever the counting of the elements come to an end, we call it as a finite set. Otherwise, we will not call it a finite set. It is called infinite set. If the counting of element, if the counting of elements of a set do not come to an end, do not come to an end, is called infinite set. Let us take another example here. A is equal to x such that x is a positive integer. It does not come to an end. That's why it is called infinite set. Now let us take one example, another example. Here's on a head. What would you say? In this case, different opinion can come. Somebody may say that it can be countable. Somebody said it is very difficult to count. But I would say that it is really a finite set because it may be a very rigorous work to do it, very difficult work to do it, but it's possible to count, however the time it takes. So that is why there are some of the vague statement also where we have to be very careful about deciding what is it, either finite or infinite. Stars in the sky, is it possible? If you specifically you say you can, but if you as a whole you take, you cannot. Now, then these all are the primary definitions of the sets. Now, I would like to say what is called cardinal number. Cardinal number. The elements of a set is called the cardinal number. The number of elements of the set is called number of elements of a set is called cardinal number. If suppose A is equal to 2, 4, 6, 8, 10, then A is a set and its cardinal number is denoted by its cardinal number is 5, which is written as NA is equal to 5, means a set whose cardinal number is 5. Now, it is very important to know about the cardinal number of a set. Why? Because it will help us to define the equal set and equivalent set. Equivalent set. What is called equivalent set? Suppose A and B are two sets, and the set A contains 10 elements, set B contains 10 elements. Whatever the element it is there, it doesn't matter. Whether they are equal or not, we can't say. But the number of elements must be same. So, let A and B are two sets whose number of elements are equal. Then we say NA is equal to NB, and hence A is equal to B. Set A and set B will be equivalent, hence, and set A is equivalent to set B. Why? Because their cardinal numbers are same. You take an example. Say A is equal to 1, 3, 5, 7, 9, 11, 12, 15, and B is equal to A, E, I, O, U, V, X, Y. Let us count the number of elements of set A as well as set B. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, NA is equal to 8 and NB is also equal to 8. So, what would you say? That these two sets A and B are equivalent to each other. But when every element of A is an element of B, then we say that it is an equal set. I'll just give an example. Equal set. If every element of set A is equal to the element of set B in the two given set, A and B, then we say A is equal to B. Not only the cardinal numbers are same, but the elements whatever A is having, the same elements of B is also having. Let us take one example. Let A is equal to X such that X is a letter of the word wolf. B is equal to X such that X is a letter of the word follow. By watching, it looks like it is a 4 elements here is 6 elements, but not. When you write in the language of the set, both of them are equal sets. How? Collect the elements of A. What are the elements of A? W, O, L, F. Elements of B. F, O, L, W. Connect it. Because I have said in the beginning only that whenever you are having the element which is going to be repeated, that is considered as only once. And so here B is equal to F, O, L also. What is there? So therefore we can say set A is equal to set B. So these were some of the primary ideas about the set. Still I have to discuss the problem. I will discuss the problem also. And next class we will discuss some more definitions. And I will send through the notes also. You don't have to worry. But I would like to request you again and again, please do not lag in your studies. Give enough time in your studies. If your basic part is stronger, if your base is stronger, if you are able to understand basically, I hope you will be able to follow up again. And every day you need the practice, every day, because I said you in the beginning of the class only that there is no connectivity with the class 10 syllabus and class 11 syllabus. Huge differences are there. To minimize this gap, you need to work. Okay, thank you very much.